In this video for VCE Algorithmics, we go into lists and arrays in a bit more detail. We'll cover slightly more than you need to know based on the study design, but it will help you when you read something else on the internet. Somewhat frustratingly, not all of the details are made explicit in the VCE Algorithmics design. Where this is the case, it's best to avoid committing to that detail either way if possible. Firstly, remember that algorithmics as a part of computer science deals with abstract conceptions of things like lists, and as such, it's very different to how Python actually implements them. I'll cover some of the differences as we go, but remember, we always go with the algorithmics definition, not the Python definition. We start with arrays. When you define an array, which is fixed in length, your operating system sets aside a chunk of memory to hold all of your array data. You'll see this referred to as contiguous memory, i.e. adjacent. The operating system needs to know how large each of the entries can be. This is partly why arrays are often said to be of the same data type, though this is not necessarily true or enforced in algorithmics exams. Once the array is defined, we can instantly jump to any item we want in the array. I know that the 15th item is a certain distance in memory from the start. Compare this now to a linked list. A list is defined with a head pointer, which points to a head node somewhere in memory. That node contains a data item and a link to the next node. This chain of nodes continues until the last node, which is marked as such. When defining a linked list, the operating system does not need to know how many items in memory there are in total, nor how large each one is. We can easily add more as we go. But to go to an item in the list, we always have to start from the beginning and cycle through every item before it in order to find it. Let's compare linked lists and arrays based on what we've seen so far. We've already said that arrays are fixed in length, and we can quickly access any item in the array by going directly to it. We call this constant time, which in Unit 4 we'll call big O of 1. Lists can vary in their length. To access an item in a list, we need to cycle through every item before it, which is linear time, big O of n. If we want to add or remove an item in an array, it takes a long time. We have to shuffle each item down one space and then add or remove the one we want. With a linked list, we find the item at the position where we want to add and change its pointer to point to our new item. Then our new item points to the next existing item in the list. This can be quicker, especially if we already know where to find the item before where we want to add our node. Insertion and deletion can still take a long time in lists. Suppose I want to insert an item before my current item. I would have to go back to the start of my list and find the item that points to the item I am currently at. Then I would change the pointer of that item to point to item 2b, in this case the new item, and make sure item 2b points to the next item in the list. This could make the process take big O of n time, which is to say we could have to cycle through every single item in the list to find the one we want. The same thing would happen with deletion. I would have to go through, find the item that points to the item I want to delete, get that one to point to the next item in the list, and then I can remove item 3 from memory. So instead, we can use double linked lists. That is, each node points to the one before and the one after. Suppose I want to insert an item before item 3. If I'm at item 3, I can use my double linked list to go back to the item before it, item 2. Update item 2 to point to item 2b. Make sure item 2b points backwards to item 2, points forwards to item 3, change item 3 to point backwards to item 2b, and we are done. We didn't have to cycle through every single item before the one we were looking for in the list. Deletion will be much faster in the same way. What's the trade-off? More memory is used in a doubly linked list to store the extra pointer. In reality, this might be quite insignificant, but remember that these concepts were developed when computers were far less powerful and RAM was measured in kilobytes rather than gigabytes. In general, for VCE algorithmics, assume you are dealing with single linked lists, not double linked lists. However, talk of double linked lists will help explain why you'll sometimes read that lists only allow the first and last items to be accessed quickly. This is an oversimplification and not something you should use in VCE algorithmics. In summary, we have covered arrays, single linked lists and double linked lists. Arrays are fixed in length, whereas lists are variable in length. Arrays are always quick to access items. Both linked lists and double linked lists are linear time, big O of n. Double linked lists have the advantage that they make it faster to insert or delete from the current item because we can go backwards in the list, and they're good for situations where you may need to go forwards and backwards. However, they use more space. Hopefully this has helped clarify some doubts you may have had about the way lists work in VCE Algorithmics. Leave your questions in the comments.